subject in lesson 5 electricity. A new topic, charges. Charge or electric charge is the basic property of matter that causes objects to attract or repel each other. It is carried by the subatomic particles like protons, electrons and neutrons. The charges can neither be created nor be destroyed. There are two types of charges: positive and negative charge. There are two charges, positive charge and negative charge. It's a symbol plus, minus. Charge or electric charge is the basic property of matter that causes objects to attract or repel each other. It is carried by the subatomic particles like protons, electrons and neutrons. The charges can neither be created nor be destroyed. There are two types of charges: positive and negative charge. There are two charges, positive charge and negative charge. It's a symbol plus, minus. Protons carry the positive charge and electrons carry the negative charge. There is a force of attractions or repulsions between the charges. Electric charge is measured in coulomb. It's a symbol of C. Next, elementary charge. Small amount of charge that can exist freely is called as elementary charge. Its value is E is equal to 1.602 into 10 power minus 19 coulomb. In the elementary charge, E is equal to 1.602 into 10 power minus 19 coulomb. This is the amount of charge possessed by each proton and electron. But protons have positive elementary charge plus E and electrons have negative elementary charge that is denoted minus E. Such protons and electrons are equal in number. An atom is electrically neutral. Attraction means unlike charges. It means positive charge and negative charge, and a negative charge and a positive charge. These unlike charges is attractive each other, and repulsion means same positive charge and positive charge, and negative charge and negative charge. These same charges is repulsive each other. Next, transfer of charges. Then electrons, that means negative electric charges in the outermost orbit of the atom can be easily removed. They can be transferred from one substance to another substance. The substances which gains electrons become negatively charged, and the substance which loses electrons becomes positively charged. The transfer of charges takes place in the following ways. The three ways to transfer charges. First one, charge by friction, charge by induction, charge by conduction. The first one, transfer by friction. Take a comb and place it near some pieces of paper. Are they attracted by the comb? No. Now comb your dry hair and place it near the comb. What do you see? You can see the paper pieces are attracted by the comb now. Because comb rubbed with hair gains electrons from the hair and becomes negatively charged. These electrons are accumulated on the surface of the comb. When a piece of paper is teared into pits, positive and negative charges are present at the edges of the pits. Negative charges in the comb attract positive charges in the pits. So the paper pits are moving towards the comb. While combing hair, charges are transferred from the hair to comb due to friction. If the hair is wet, the friction between the hair and the comb reduces, which will reduce the number of electrons transferring from hair to comb. Hence, rubbing certain materials with one another can cause the build-up of electrical charges on the surfaces. From this, it is clear that charges are transferred by friction. Similar effect can be seen when we rub few materials with one another. When a glass rod is rubbed with a silk cloth, the free electrons in the glass rod are transferred to silk cloth. It is because the free electrons in the glass rod are less tightly bound as compared to that is in silk cloth. Since the glass rod loses the electrons, it has a deficiency of electrons and hence acquires a positive charge. But the silk cloth has excess of electrons, so it becomes negatively charged. But silk cloth has excess of electrons, so it becomes negatively charged. When an ebonite rod made by vulcanized rubber is rubbed with fur, the fur transfers electrons to the ebonite rod because the electrons in the outermost orbit of the atoms in the fur are loosely bound as compared to the ebonite rod. The ebonite rod, which has excess of electrons, becomes negatively charged, and the fur, which has deficiency of electrons, is positively charged. From these, we know that when two materials are rubbed together, some electrons may be transferred from one material to the other, leaving them both with a net electric charge. Second one, transfer by conduction. Take a sheet of paper, turn it into hollow cylinder. Tie one end of the cylinder with the silk rod and hang it from a stand. Now take an ebonite rod and charge it by rubbing it with a woolen cloth. Bring this charged ebonite rod near the paper cylinder. The cylinder will be attracted by the rod. If you touch the paper cylinder by the charged rod, you will see the paper cylinder repelling the rod. Can you say the reason? When the ebonite rod is rubbed with a woolen cloth, electrons from the woolen cloth are transferred to the ebonite rod. Now, ebonite rod will be negatively charged. When it is brought near the paper cylinder, negative charges in the rod are attracted by the positive charges in the cylinder. When the cylinder is touched by the rod, some negative charges are transferred to the paper. Hence, the negative charges in the rod are repelled by the negative charges in the cylinder. Thus, we can say that charges can be transferred to an object by bringing it in contact with a charged body. This method of transferring charges from one body to other body is called transfer by conduction. Third one, transfer by induction. The process of charging an uncharged body by bringing a charged body near to it but without touching it is called induction. Bring a negatively charged plastic rod near a neutral rod. When the negatively charged plastic rod is brought close to the neutral rod, the free electrons move away due to the repulsion and start piling up at the further end. The near end becomes positively charged due to deficit of electrons. When the neutral rod is grounded, the negative charges flow to the ground. The positive charges at the near end remain held due to attractive forces, and the electrons inside the metal becomes zero. When the rod is removed from the ground, the positive charges continue to be held at the near end. This makes the neutral rod a positively charged rod. Similarly, when the positively charged rod is brought near the uncharged rod, negatively charged electrons are attracted towards it. As a result, there is excess of electrons at nearer end and a deficiency of electrons at the further end. The nearer end of the uncharged rod becomes negatively charged and the far end is positively charged. I hope all are understood today's topic. Thank you for listening, students.